but nobody calls.
Stop. You're not allowed to.
Okay, we don't know. This is the one problem that we don't know whether it's an identity, a contradiction, or a conditional equation. So, does that change the way we go about doing this?
No.
Really should. Which side do you want to work on?
The left.
Good idea. Where do we start? They are what? They're conjugates. Yeah, I would multiply these together first. Could you distribute the cosine squared of x first? You could. It would make it infinitely uglier. Yeah, why was a very good question, I think. All right, so cosine squared of x times tangent squared of x minus secant squared of x equals 1. Fair? Okay. What rings a bell?
Tangent squared is minus.
You think that might be an identity somehow in the parentheses? Okay, so 1 plus tangent squared of x equals secant squared of x. That's the way I see it. So tangent squared of x minus secant squared of x
Equals -1.
equals -1. Would you agree with that? If we subtracted the 1 from both sides, and then if we subtracted the secant squared from both sides, so we'd get -1. So, I see it as cosine squared of x times -1 equals 1. Do you see it that way? Which therefore means the left side is negative cosine squared of x equals 1. Are we done?
No.
We can simplify more? I'd say we're pretty well simplified, aren't we? We got it about as simple as we can get it. Is that an identity?
No.
Is it a contradiction?
No. No. Yes.
Can that statement be true?
Yes.
Yes. Oh wait, no, because you can't put it on.
Yes.
Can we do this?
It's a condition.
No.
Well, I mean, is it okay to go from there to there?
Oh,
Yes.
Okay. Can this statement happen?
Yeah.
Somewhere between yes and no, I would agree.
But you not have a negative.
So most people, so I would say that there are two thoughts going on right now. The first thought is, well, cosine of x can be -1, which is a good thought. That is a true thought. But for cosine squared of x to be -1, cosine of x would have to equal,
Well, you can think negative squared. Positive.
it would have to equal,
It would have to equal negative. Well, it can't. Expansion.
it would have to equal I, right? Because if we square a real number, it's going to be
Positive.
positive. Therefore, this statement is a contradiction. It cannot possibly happen. Is that what the back of the book said?
Yes.
Good.
Wait. Yeah.
Yeah, this one can't happen.
I don't think it's a condition.
The funny thing is, we had flipped these around, which therefore would have had secant squared minus tangent squared, then we would have been okay. Then it would have been a conditional statement, because we would have had cosine squared of x equals positive 1, and then that would have been okay. It's not all the time, but it can happen.
47.
That was coming. I knew 47 was coming.
The answer is no, this can't happen. Okay, that's what I thought. Oh, yeah, that's annoying.
I will tell you, the first time today I looked at this, I said, oh my. But then we just started jumping into it, and it's not as bad as you think. Anything you don't like? Don't say everything.
Fractions.
What I don't like is the fact that we have sines and cosines.
Yeah.
Like over here, I don't like the fact that we have cosine squared and sine right around each other. There's really nothing we can do with that. So can we change that at all?
Yeah.
How?
Because cosine squared of x
So let's change cosine squared of x to 1 minus sine squared of x. Is that okay? Do it on the bottom too, or just kind of leave the bottom?
And do it on the bottom too.
Do it on the bottom too. So we'll do that also. So 1 minus sine squared of x plus 3. Okay. What's on the top? 2. Can I do plus sine of x minus sine squared of x? Is that okay? And on the bottom? Or minus sine squared of x. It's interesting because any little mistake here just blows it up. If you add wrong or subtract instead of adding or add instead of subtracting or something like that, and all of a sudden you have no chance of this. All right. Thoughts now? Factor? Top or the bottom? Both. Here's how I know we have to factor the top. Okay? We have a sine squared and a sine. If we have a sine squared and a sine, we're pretty much going to have to factor. So we factor the top. And then factoring the bottom, if we're going to factor the top and the bottom is factorable, is the bottom factorable? Then we should probably factor the bottom also. So I would factor both. Let's talk about the top. Tell me about what's first in each parentheses.
Sine x.
2,
2 and 1.
2 and 1. Right? How do we get 2? It's got to be 2 times 1.
Okay.
With me?
No.
Okay. What's second in each parentheses?
Fine.
Sine of x. Okay. I wasn't communicating that well. I understand. Are we okay with this? All right, because 2 times 1 gives us the 2, and sine of x times sine of x gives us the sine squared of x. So, what does that minus sign tell us?
Different signs.
The signs inside are going to have to be different. So we know that. And then we need a plus sine of x. So how can we do that? Let's see. 2 times sine of x is positive, and 1 times sine of x is negative. Does that work it? Missed.
Close.
Bottom,
2 and 2.
2 and 2. Sine of x and sine of x,
Plus and minus.
plus and minus. Oh! There's good news here. The 2 minus sine of x is cancel, which gives us 1 plus sine of x over 2 plus sine of x. Okay, let's see what we have to do now.
Whoa.
Whoa.
And we're done. We okay there? That one's not an easy one. There's no question about it. But the reality is, even though it's not an easy one, there weren't a lot of hard steps. It's just a matter of knowing which steps to take. And there's only one way to get better at knowing which steps to take. Practice. Absolutely. And there is nothing I can do, short of cheating, to make it easier for you. Capiche? All right, can we move on?
Are we on 7.3 now? Yeah. No.
7.3.
Yeah.
I didn't be yesterday.
I have no clue what I upload half the
Anybody still
time.
need the brown one?
Honestly. It's just 7.3.
Okay. So we finished 7.2. We finished 7.1, we finished 7.2, so now we go to the obvious place that comes next.
7.3.
7.8, of course.
What?
Goes without saying. It's obvious.
Of course. Wait, what?
Sign.
Are you in 7.8?
Who are?
Yeah, we're in 7.88. He was being serious.
Okay, I couldn't tell. Oh,
Oh, we're bringing it back.
that's nasty.
What are we back to?
Theta?
Numbers.
Oh,
Anything
man.
else that we're back to?
Theta? Oh.
Inequalities.
Nope, that's not what it's called.
Something else that we're back to?
I don't know. Restriction?
You're going too deep. Not deeper than I'm planning on.
Inequalities?
Sandwich statement?
Solving equations?
Sandwich statement?
I didn't want numbers back. I didn't miss them.
Graph.
So
I know.
Been,
Nice. Good break.
we've been verifying identities. We have been simplifying trig statements, trig expressions, and stuff like that. And we've gone away for a little bit from solving equations, but we're going to go back to solving equations
I
right
didn't miss numbers.
now. Okay? This stuff, I think you can do this stuff. I think we've already done some of this stuff. So when you look at this problem, what are some of the things that jump out at you? Okay, so we got a sine of x, so we got a trig statement. What else?
2 pi.
Pi, what do you mean?
It's in radians, yeah.
It's in radians. So this problem is going to have 1 answer, 2 answers, 4 answers. I don't know how many answers it's going to have, but the answers that we come up with must be in radians, because that's what that tells us right there. Okay. Sine of x is negative root 2 over 2. Is this a calculator problem? No, why not?
Chart.
It's a chart problem. It's a chart problem. Tell me the angle.
45
45
degrees.
degrees, which in the radian world is
Pi over 4.
4. So is that fair? What did I call pi over 4? Reference angle. Is that true?
Yes.
Okay. What do we have to do with pi over 4?
Multiply it, or find all the, the cost, 5 pi over 4.
We need to what?
Quadrant.
We need to put it in the right quadrants.
Oh,
How many quadrants will be good here?
2.
2. Which quadrants will be good
3
here?
and 3 and 4. 1 and 3 and 4. 3 and 4.
Which quadrants will be good here?
3 and 4.
Quadrants 3 and 4. So what we're trying to do here is take pi over 4 and put it into quadrants 3 and 4. 4. I kind of remember that. We did a little something with that, didn't we? We said that pi over 4 in the first quadrant is just pi over 4. In the second quadrant, I remember talking about this a little bit. What was it in the second quadrant?
3 pi over
3 pi over 4, that's right.
Oh, right, it goes by
3 pi over 4. Then 5 pi over 4.
7.
7 pi over 4. So therefore, x, I put x. I think that, yeah, I put x there and theta there. That was a bad move on my part. They should both be, in this case, they could either both be x's or both be thetas. They are giving you thetas, so I'll write it as theta. Sorry about that. So theta is
5 pi over
5 pi over 4 because that's quadrant 3.
7 pi over 4.
7 pi over 4 because that's quadrant 4. And those are our answers.
Oh, that wasn't.
And I believe we've done some stuff kind of like that
5 pi over 4 and 7 pi over 4.
earlier. So hopefully that's not too bad for you.
5 pi over 4 and 7 pi over 4. Because it's 45 degrees.
So-
That wasn't as horrifying as it appeared.
Let's
135 degrees. That's what you're just writing.
step it up.
We don't have to. You're adding 96. Oh, nice. It's just 45 to the x-axis. That's the correct quarter 10, I guess. No, this is not. I need to put it in.
Is it 2 theta?
That is 2 theta.
Oh, I thought it was 20. Oh, so did I.
Okay, talk to me.
Is the reference angle 120?
I don't know. Well, how can a reference angle be 120?
yeah, that's not six.
Sorry, no.
No, don't yell at him. I can yell at him. Well, talk me through it, because there's no doubt in my mind you're going in the right direction, but just start at the beginning.
The reference angle is going to be double, isn't it? 30.
Oh, yeah.
So, okay, what's weird about this problem? What's different? What's
2
new?
theta.
2 theta. Okay. I do not want us to deal with the 2
Okay.
for a long time. Let's go through this problem as if there is no 2. And we'll worry about the 2 at the end. So, get started. What are we talking about here?
The reference angle is
Yeah, cosine of something is square root of 3 over 2. What's the something?
30.
30 degrees.
Pi over 6.
Yeah, I don't like 30 degrees here because
It's in radians.
it's got to be in radians, so pi over 6. So I like pi over 6. Pi over 6 is our reference angle. Which quadrant or quadrants are we talking about in this problem?
2 and 4.
1
1 and 4.
and 4. I would agree. So we need pi over 6 in the first quadrant and the fourth quadrant. Okay? Sound good? All right, what's pi over 6 in the first quadrant?
Pi over 6.
Pi over 6, we like that. What about the fourth quadrant?
11 pi.
So we're talking about there?
Is it 3?
And so this angle right there is pi over 6?
Yeah.
So it's pi over 6 away from
2 pi.
2 pi, right?
So it's 11
So
pi over
it's
6.
2 pi minus pi over 6. Is that fair? With me at all? You okay with the pi over 6 being here? Okay, so it's pi over 6 before 2 pi. So if we're doing this angle, it would be 2 pi, but it's just pi over 6 short of it. So 2 pi minus pi over 6. Now, we need to get used to how to deal with this. Yeah, absolutely. And as time goes on, you're gonna know this a lot quicker, a lot faster, a lot easier. If you're not really sure what to do with this, don't, basically eliminate the pi. Treat it as 2 minus 1/6. And we'll stick the pi in at the end.
11 over 6.
So 2 is
12 over 6.
12 over 6. So basically, we have 12 pi over 6 minus pi over 6, which gives us 11 pi over 6. And 11 pi over 6 is in the fourth quadrant. Okay? Questions there? Okay.
Why is it 12?
Now,
Just 2 pi
we deal with the
over
2.
6.
Now no, we're not done. In fact, God bless you, we're not that close to being done. We have to deal with the 2 in 2 different ways here. Okay? The first one I believe we talked about at some point, kind of a long time ago. Can't really remember what the topic was that we were talking about it on. But the first way that we deal with the 2 is that we're going to go around twice. I think we talked about that with something else that we had done. If we have a 3 theta, we would go around 3 times. If we had a 5 theta, we would go around 5 times. If we had a 72 theta, we would
Hopefully not
drop the course, right. If we had a 1/2 theta, or theta over 2,
Go around half.
we would only go halfway around. Okay? So those are the things that we have to pay attention to with that. Okay? So, in this case, we have to go around twice. How do we go around twice?
That's great.
But we can't do that.
Don't worry, we'll take care of that. But we have to though. Okay? So, remember how we go around an extra time. This goes all the way back to the beginning of trig. It talks about, do you remember the phrase? 2 words, first one started with C.
Co-functions?
Co what?
Terminal.
Co-terminal angles. Is that what you said?
Right, yeah.
Speak up, say it louder. Coterminal angles. How do we find coterminal angles? We either add 360 or subtract 360 or add 360s or whatever. Now in this case, we're not adding 360, we are adding 2 pi. 2 pi is 12 pi over 6. So if we add 12 pi over 6, we will get 13 pi over 6. And if we add 12 pi over 6, we will get 23 pi over 6. And that is way number 1 or part number 1 of dealing with the 2 in front of the theta. The 2 says we have to go around twice, so once we have these 2 angles, we just add 2 pi to each of the angles, and it gives us 2 more angles, and now we have 4 angles. Because 2 pi yes? So because these are both 6's in the denominator, okay?
Wait. How do we go from 13 to 23?
I didn't. I went from 11 to 23. We added 12 pi over 6. So we added 12 pi over 6 to that to get that.
Oh, okay.
And then we added 12 pi over 6 to that to get that. Is that okay? Cool. All right. Those are not thetas. Those are
Reference.
2 thetas.
So we divide
Right?
by 2.
We want to be getting the cosine of these angles. If we find the cosine of this angle and this angle and this angle and this angle, the cosine of every one of those angles is root 3 over 2. But that's not what theta is. That's what 2 theta is.
we
So
divide
2
by
theta is pi over 6, and 2 theta is 11 pi over 6, and 2 theta is 13 pi over 6, and 2 theta is 23 pi over 6. If we want theta,
Divide by 2.
you'll have to divide by 2, which is the same thing as
Multiplying by 1.
multiplying by 1/2. And what's the simplest way to multiply by 1/2 or divide by 2 if we're talking about a fraction?
Denominator by 2.
Double the denominator. So if we divide by 2, multiply by 1/2, whatever we're doing, this will give us pi over 12. And if we look at each one of these dividing by 2 or doubling the denominator, we will get pi over 12 from this one, 11 pi over 12 from this one,
13.
13 pi over 12 from this one,
23 pi over 12.
23 pi over 12 from this one. And those are our answers. And what you will find, for all of you who were stressing out about this, is that these 4 angles all do fit in between 0 and 2 pi. Yes, sir?
I don't understand how the first 2 angles we found, pi over 6 and 11 pi over 6, are 2 theta as well. Because didn't we just, that was like when we just went around once.
Yes. The going around twice just means that we're going to have more angles, okay? But cosine of pi over 6 is square root of 3 over 2. But if we said that theta was pi over 6, then tell me about the cosine, ooh, that wasn't what I wanted. Tell me about the cosine of 2 theta. If theta is pi over 6, then 2 theta, wrong way, 2 pi over 6, which is pi over 3,
Oh,
yeah?
Yeah.
So if theta is pi over 6, we'd have the cosine of 2 times pi over 6, which is the cosine of pi over 3, and the cosine of pi over 3
Is around 1/2.
is 1/2. So if we plug pi over 6 in for theta, we don't get the right answer. Because we're finding the cosine of 2 theta. So this is what we want pi over 6 to be. Okay? We want 2 theta to be pi over 6. We want 2 theta to be 11 pi over 6. Is that making any sense?
Okay.
Okay. I was waiting for that where I can see the light bulb it just hit. Does that make sense now? Yeah. Other questions on that?
It's kind is sort of like that, but how you said like with the 2, and if you change it to like a half or whatever you put in front of theta, would the domain still be the same?
Well, they're gonna give us the domain,
Okay.
so we don't have to worry about that. What we're doing right now is just kind of dealing with it all as 0 to 2 pi. So assuming that and they're not always gonna give us 0 to 2 pi, so that's gonna be an interesting thing in your homework tonight also. But I'm less concerned about that, so don't worry about the domain, just follow through basically on what we did.
Okay.
Okay? Others here? Yep.
How do you determine the quadrant?
Because cosine was positive. And cosine is positive in first and fourth because all students take calculus. So first and fourth are positive, and so is that what you were asking? Good. Others there? All right, next one.
What day do you test on this week?
We test Thursday and Friday next week.
No, but like what day do you test on? Because you only test one of the 2 days.
I don't remember.
Does that look a lot harder, a little harder, easier, or about the same?
Looks harder.
What don't you like?
The 4 and the 8.
The 4. You don't like the 8 and the 4. Okay.
Or the cosecant.
Or the cosecant. All right.
Yeah, can you just move it to the
Say it again.
We can do that now.
Can't you just subtract the 8? Yeah. Great idea. Let's do it. 4 cosecant of 2 theta equals -8. Divide the 4. I squeaked. Divide the 4, -2. We're getting better already, aren't we? Okay, the 8 and the 4 are certainly a lot less intimidating when you just subtract the 8 and divide the 4. Now what don't you like? I don't like cosecant either. Can we change it?
1 over
Okay,
sine.
tell me what to write.
1 over sine.
I don't want to write 1 over.
Let's do,
Can I write,
Yes.
I don't think so.
what did I do?
Found the reciprocal.
Just put
Took-
sine.
The reciprocal.
The reciprocal. Did I just take the reciprocal of that?
Yes.
The reciprocal, hang on. The reciprocal of the cosecant of 2